Our math skills today is putting together the times when we have energy on these increases where the temperature does change when it's a solid, a liquid, or a gas, and it hasn't changed phase, it's just heating. So that would be using Q equals mcat, and using our latent heat when a phase change is actually occurring and no temperature change is seen. So that would be using Q equals HM. So we are going to do a practice problem together for number 1 and use the appropriate piece of information from the heating curves to help us solve it, and then add our energies together for each section. Suppose during a volleyball game, some of your body's water heats up from 98 degrees to 100 degrees. So that would be right here on our heating curve, but nothing's boiling. It's still water. Your sweat is not boiling into vapor. It's just heating up in this. So we are going to be using this section, specific heat, which is 4.184 joules per gram degree Celsius. We have energy, we have temperature change, and we want to find mass. So our Q equals mc delta T. Let's solve for our mass. So if we do our math and we multiply the product of 4.184 and 2, and then we divide that over, we are going to get mass equals 755 grams of sweat. Ooh, that's a lot of sweat. Sweaty game. Okay. Now it says, how much more energy will the water need to absorb from your body to completely evaporate? So now we're going to hit this section. How much until it completely evaporates off of your body? This time on our heating curve, we are going to be using heat of vaporization. So we have our mass we just calculated, we have heat of vaporization, and we are ready to solve for this energy. So the energy required is going to be a lot because that's a lot of sweat. 1,706,300 joules. And the last one asks, what is the total energy expended by your body to raise the temperature of the sweat from 98 until it completely evaporates? So this question is a combination of A and B, worded differently. So we're raising the temperature from 98, so that's when it's still water, until it completely evaporates all the way through to this point before it's all in the gas phase heating up. So we're going to need, I'm going to call this Q1 and call this Q2. So when we're finding a total energy, we can say that Q total, or the total energy, is the sum of the others that we calculated. So if we just add up Q1 and Q2, we'll have the total energy expended by your body to both raise the temperature of the water and then to evaporate it. To raise the temperature, those 2 degrees, was 6,315. And then we want to add the additional energy to evaporate it, which is a lot. So our total energy comes to be This is rounded. This is a rounded value. Joules. And I'm going to write this in kilojoules since we have such a large number. 1,713 kilojoules. That's the total energy required to both heat it up and then change its state into vapor by evaporating it. So that's going to be your process whenever you're working through one of these problems. I want you to think about how many Q's are going to be required, and the way that you will know is by checking to see if it is simply raising the temperature of a single state of matter or if it's changing state. So the next one, I'm just going to help you map this out and then leave you to it. It says how much energy will be absorbed by 150 gram sample of ice at 0 degrees Celsius. So that's starting here. That melts. So we're going to go all the way through heat of fusion and then warms to 25. So we've got two sections again. This will be Q1 and Q2. So our Q1 is using Q equals HM with heat of fusion. And our Q2 is going to be doing Q equals MCAT with our specific heat of water and a temperature change of 25, 0 to 25. So setting up our equation, we'll do H and M, 150 grams. So there's Q1, and then Q2, M, C, and it went from melting point 0 up to 25. So there's our delta T. And then to find that total energy, add them together for your total to solve. So I'll let you do number 2 the rest of the way. The rest of them are the same process, so map it out on your page and then work through it. Number 3 is a little bit different because it asks for what mass of water would be boiled away. So in this case, you are going to need to find kind of the energy remaining from this given amount that it provides, and then see how much mass. So I will help you set this one up as well, since it's a little bit different setup. You put a pot of water on the stove, so we're in water, somewhere around here, 20 degrees Celsius. Okay, so we're going to start at room temperature, and then what mass will be boiled away. So what we're going to do is we're going to find Q1, and then we're going to see how much is remaining for Q2 to be able to see how much actually can boil. Okay, so we will start with Q1. That's Q equals MCAT. It's in the water section. So we've got our mass, we've got our specific heat, and we're going to go from room temperature 20 all the way up to the boiling point, which is 100. So that would be an 80 degrees increase. Notice it doesn't tell you the delta T, but it does say it's going to be boiling away. So we're approaching that boiling point, and that's how we know it's going to be going all the way up to 100 degrees with that 80 degree increase. So you'll find this energy, which ends up being 150,624 joules. And now we're going to find that remaining energy, because that's going to be what will tell us how much we can actually boil. So remaining energy, if we've got 325,000 joules To start with, let's subtract out how much it was required to raise the temperature to the boiling point. And if you subtract those, we get 17,476 joules. So now the problem is solve for mass in this boiling section. And we know Q2 will be this value. This is Q2. Okay, so we're not solving for Q2. We're using Q2 to now find mass. Okay, so we've got this section is a Q equals HM with heat of vaporization. So let's solve for M, plugging in Q and H. So we've got Q equals H M. If we divide those, we will get M equals 77 grams. So our answer here is that 77 grams of water would be boiled away. So 77 grams of water will boil. Not all of the pot of water. Sometimes you'll need to find remaining energy in order to answer the actual question rather than finding a total energy for the sample. So read all the parts of the question before you answer it or before you think you're finished. You have a few more problems on this page. Map it out with the heating curve. Add the energies together to find a total energy. Number 6, this is a typo. This should be 10 to the second power, not 102. So that is 400 grams. Just a little note there. Okay. That's all I got for you. Good luck.